Hello everyone, welcome to Sci-Ease. In this video, I am going to start with a chapter, Carbon and its compounds. First, I want to tell you something about carbon. Carbon is a non-metal. It has symbol C. It has symbol C. And its atomic number is 6. Carbon is found in the earth crust, very little carbon, that is 0.02% of carbon is there. And in air, it is 0.03% in the form of carbon dioxide. It is very important element in all living beings, because fats, proteins, vitamins all contain carbon. Organic compounds, they are made up of carbon. Carbon, we wear clothes of polyester, nylon, rayon, all contain carbon. So carbon is very, very important element of the periodic table. Now carbon has atomic number 6 and its electronic configuration is 2,4. Means 4 electrons in the outermost shell. In K, it can accommodate 2 electrons maximum. Then in L shell, it has 4 electrons. And I have told you that every element has a tendency to acquire the noble gas configuration either by losing the electrons or by gaining the electrons in ionic bonding. I told you that. If carbon loses 4 electrons and result in the formation of C4 positive, lot of energy is required. In the same way, if it gains the electrons, it will result in the formation of C minus 4. Again, it's very difficult. So, carbon, it shares the electrons with itself or with the other elements and results in the formation of a covalent bond. So I want to tell you about covalent bond, what covalent bond is. So my topic is bonding in carbon as well as the covalent bond. I want to tell you in other elements also how this bond that is formed. Covalent bond, the chemical bond formed by sharing of the electrons. In ionic bonding, there is transference of the electrons. But here, the sharing of the electrons takes place between the two atoms. A covalent bond is formed when both the reacting atoms need electrons. Why they need electrons? To achieve the noble gas configuration, or you can say inert gas configuration. In order to explain this, I will take many examples. This bond, how it is formed, how we will represent it, it is represented by a single line. And this represents one pair of the electron, 2 electrons. Covalent bond is of 3 types: single covalent bond, double covalent bond, and triple covalent bond. So I will take the examples. Non-metals, 2 non-metals, they will result in the formation of the covalent bond. Here we will take the case of hydrogen. Hydrogen has only one electron, and this I have represented by cross. You can put dot also, you can put cross also in order to represent the electrons. So it has one, and one hydrogen is very reactive. It can't exist as H. It can exist only as H2. So one electron from one hydrogen atom and one electron from another hydrogen atom, they will share these electrons and they will acquire the nearest noble gas configuration of helium. Like this, I will represent it like this. Circle, I will draw. Duplet of this hydrogen is completed, and this hydrogen will again have 2 electrons. And how I will represent this? H, H. So this is the simplest example of covalent bonding. Covalent bond that can be formed in case of halogens, Cl2, F2, Br2, I2. I will take the case of Cl2. One chlorine has electronic configuration 287, 17 atomic number. Chlorine. 17 atomic number we put here, just on the left hand side at the foot of the symbol. Now its electronic configuration is 287. We will take only the outermost electrons, or you can say valence electrons. I have represented it by putting cross 7 and 7 of this atom of chlorine. Now what is the result? This chlorine will share this one electron, and the octet of this chlorine will be completed. It has acquired the nearest noble gas configuration, and this chlorine will also share this electron, and it will result in the formation of this, its outermost shell that is completed. 8 octet you can say. So what will be the result? There is formation of single bond. So Cl, Cl. These electrons which are outside the chlorine, which have not taken part in the bond formation, they are known as unshared pair of electrons. Now you can take the case of oxygen. I have told you that covalent bonds are single covalent bond, double and triple. Now I will take the case of oxygen. Oxygen has atomic number 8. So its configuration is O8. So electronic configuration is 2, 6. So one oxygen, it has 6 electrons around it, and another oxygen also has 6 electrons around it. Now in order to complete the octet, this oxygen will share 2 electrons of this oxygen, and this oxygen, the second one, that will share the oxygen of other 2 electrons of other oxygen atom. Now, in order to complete the octet, it has shared 2 pairs of electrons. So, how many bonds they will be formed? Here there is bond formation, 2 bonds they will be formed like this. Okay, so O2 will be formed. How? O double bond O. And how many unshared pair of electron? 2 around this oxygen atom and 2 pairs around this oxygen atom. So here the double bond that is formed. Now take the case of nitrogen. Nitrogen has atomic number 7. Atomic number, nitrogen. First you write the symbol, then this is 7. What it is its electronic configuration? Its electronic configuration is 2, 5. So you are to represent these electrons here so that they can share the electrons easily. So nitrogen, it has 5 electrons in the outermost shell, and here it needs 3 more electrons to complete its octet. So this nitrogen will share 3 electrons of other nitrogen atom, and its octet is complete. In the same way, this nitrogen will share the 3 electrons of other nitrogen atom, and its octet is also complete. So how can you represent? Now how many bonds they are formed here? Here 3 bonds they are formed between nitrogen. You can show it like this. So N triple bond N, and this you can share unshared pair of electrons. So this is N2 molecule. Covalent bond. Now come to the case of carbon. Carbon can form 4 bonds around it. That is why we say that carbon is tetravalent. So we will take the case of methane, CH4, this. I have told you that carbon has 4 valence electrons. I will represent this by black cross, 4 electrons around carbon. And hydrogen, it has only 1 electron. That I have represented by blue cross. So what will be the result? The bond that will be formed between carbon and hydrogen, this. 2 electrons can form a single bond. Here also, and here also. So what about carbon? Carbon will share all these electrons, and its octet that will be completed. So the result will be CH4 molecule methane, which is very important. It's a component of natural gas. It's very important. Now you can take the case of carbon tetrachloride, CCl4. Carbon has 4 electrons. I have put black cross around it. You can put dot also. Now chlorine has, as I have already told you, 7 electrons. So 7 electrons I have represented by blue cross. What will be the result? Chlorine will share this 1 electron of carbon, each chlorine, and result in the formation of this. Its octet is complete. The octet of this chlorine is complete. Octet of this is complete. And octet of this carbon is also complete. What about carbon? In carbon, again, here it will share these 1 electron from each chlorine, and the octet that is complete. So what is the result? CCl. How you will represent this? C in the middle, Cl, 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 and Cl. So this is CCl4. Now I will take one alkene, that is ethene. Ethene has formula C2H4. Now carbon has 4 electrons. I have put blue cross around, 4 blue crosses around the carbon, this carbon and this carbon. Hydrogen has only 1 electron. This I have represented by black cross. So what will be the result? How many bonds they will be formed? The duplet of this hydrogen, that is complete. It's complete, and here also, and here also. Now what about carbon? And here the 2 bonds, they will be formed. So while writing C2H4, or it is ethene, while doing this unsaturated hydrocarbons, I will tell you again, double bond C, H, H, H and H. Now take the case of ethyne. Ethyne. Now how many bonds they will be formed? Here this carbon will share these 3 electrons, 3, 3, 6, 7, 8. And this will share again these electrons, and this is formed. Duplet of hydrogen, that is completed, and here also it's completed. So how will we represent this? C, triple bond C, H, H. So this is the example of triple covalent bond. This is the example of double covalent bond. Very simple example in case of HCl. Here 7 electrons I have represented around Cl and 1 around hydrogen. It will share these electrons and this octet, that is completed. So here HCl, that is formed. There are many other covalent compounds also, like water, ammonia. I can take the case of water. Here it is H2O, formula of water, HOH. Now around oxygen, how many electrons? 6. And around hydrogen, only 1 electron around each hydrogen. So what will be the result? Like this. This is like, and then it is like this. Okay. Now these 2 electrons, which I will represent like this, these are lone pair of electrons. They are also known as unshared pair of electrons. They are also known as lone pair of electrons. And this is HOH. They will remain here. This will reduce this bond angle, and it is 104. So I have told you about the covalent bond in case of carbon as well as in other compounds. So these are all the example. Ammonia is also the covalent compound. You can represent it like this by putting dots or by putting these crosses around them. So what covalent bond is? The chemical bond formed by sharing of the electrons. Here the electrons are being shared. So this is all about the covalent bonding as well as specifically in case of carbon also I have told you. In the next video, we will discuss about the versatile nature of carbon. Thank you.